So, welcome to the video tutorial for the in vitro motility analysis. So this should be like the first relatively simple tutorial, just how to get started and how to do a first relatively simple analysis. So as a courtesy to everyone, I'd start with actually showing how you can download the software from the online repository if you haven't installed it yet. So if you have already installed the software, then probably you don't have to look at and listen to the first parts of this video. So you can see here the address of the repository where you can actually go and get all the source files that will be necessary to run the software. And as you go here, you can see on the right side here there's download zip, which will get you basically all the files that you see here in one shot. So let's do this. It should be relatively quick. You can open it right away. Yes, it's already here. So I'm gonna select all of these here and extract them. On the workstation we have a results folder, mine, tutorial videos, and yeah, let's just go into here, create folder IVMA3. That's where things are going to be stored over here. So this is the software that we just downloaded from online. So that's basically all you need to do. If you have MATLAB installed, you're just ready to go from here. Now what we want to do today is to analyze just a couple of videos. Say you just recorded from one flow cell the motility from there, and all you really want to know is what is the velocity that you saw in there. So we're going to look for the videos that we're going to analyze, and we have here all the videos stored on our storage drive. Videos, pick one from here. Phosphate assay, no. Here, that should be a good one. And then we go into valid data. Sounds good. And I checked before, the 7th of October should be a good folder to work with. So we're just gonna take this whole folder here and copy it over to the same folder that we just copied the software to. So that's here, results, my folder, tutorial videos, and Excel analysis, and we just put them. Didn't copy it yet. Copy and paste. It's going to take a short moment. It's a relatively big file. Transfer this over. So I'm already going to go and check what's actually inside of this folder. So we see a couple of slides appearing here. Then why don't we just take slide 3 here, and there's a bunch of AVI video files in here. So we want to actually analyze these 8 files here using the software, and after that we are going to use a spreadsheet analysis program. You would think Excel, but we use an open source alternative to that, but it works in pretty much the same way, and then we'll get the sliding velocity from these videos here. So let's get MATLAB up and running here. again takes a little moment to come up. Alright, there's a bunch of things open here, but we're actually going to work with the files that we files that we just downloaded from online. So we go into the workstation directory and find the directory that we downloaded to just before, tutorial videos, Excel analysis, IVMA3. The file you're going to want to be working with is the analysis launcher.m. Here .fig won't get you too far, but this is the right one to work with. So it opens up here. You see there's a bunch of scary code coming up, but really what you want to go for is this run button here. The option to take here would be change folder. You don't want to add this to the path, so change folder to move forward. And here we are. So this is sort of the central interface you're gonna be working with. First option you have is to either work with a single AVI file, so it's a single video, or as we were looking at before, with a directory or a folder, a root folder that contains several videos that will be processed as a batch. Root means that you would start from a folder. It can have subdirectories, which in turn can have subdirectories, so really every video that's inside of a start or root directory will be considered. So let's pick a source directory here. Let's go up. These are the data that we just pulled from the other hard drive and copied over. Here, slide 3 that we picked before, and we're going to take any videos that are in this folder. You can't see them here, but as we saw here in the File Navigator Explorer, there are 8 videos in here, so let's use these. As a target, you would decide where the results of this analysis should actually go. So maybe we just create another folder here that's going to contain it. So we say 7th of October, 11 analysis results. Go into here and pick that. So you can check here where you're actually going. So you want to make sure this is the right source. And this is the right target to put things into. And then we have to set the parameters for our video analysis here. You can go into detail on these in another video or in the manual if you want. For now, we're just gonna take this and run with it. So really what we just have to do is start the analysis now. So there's one thing here that I quickly have to inject. While recording it, I did not mention the magnification factor. The magnification factor is extremely important because it will determine the actual velocities that you measure from the videos. The magnification factor is given in units of micrometers per pixel. Micrometer is, well, the length in the assay, or length on your recording slide. And a pixel is 1 pixel in the videos that you record from your experiment. So this means that in our case, this 0.098 here means that if we have the edge of one of our pixels in our videos, this would actually be 0.098 micrometers in length, or 98 nanometers. So this is really the point where you go from what you record as a video, as a pixel, to a length that is happening inside your assay. So before you can get absolute velocity values, you will actually have to find out what this is in your case. If you don't, the velocity values that you will get out of there are not correct. So you need this value, and you enter it before you start the analysis later. So watch out for this. You need to find out this value for your specific experimental setup and enter it here, and only then will you get correct results out of this. So that was the quick intermission. here is a friendly reminder to not go and start clicking in this interface while things are running, because you might accidentally actually start a second call to an analysis. So once this one is done, it just would do the same thing again, which is not really useful. Anyway, now you want to check on the progress of our analysis on the command line of MATLAB. So this is like the main MATLAB window. And here you can see that the analysis launcher was executed before. Then with clicking start analysis here, we actually made the call to the analysis function. And then you can see how it's going through the videos in sequence, which then is taking some time, so we just have to wait for that. It is much faster though than doing this by manual analysis. So I, for my part, would not complain too much now to wait a little. So, recording is still running. Yeah. At the same time, while this is running, we could actually go and look at the results that this is putting out at the moment. So here is the analysis results folder. Let's go into here. You can see that there are new folders appearing inside here, and if you look at the names a little more closely, you can compare these to the names of the video files here, and you would actually realize that the name of the folders that are contained in here are just the names of the video files minus the .avi in the end. So you can see that for every video that is being analyzed here, there's actually a folder recreated that will contain the results from analyzing this video. I think this one here should be relatively safe to look at, so we can go into here, and you can see that there inside of this folder there are 3 files, namely the analysis results in .mat. This is a MATLAB specific format, so we're not going to deal with this right now. They're the parameters coming out of this analysis. If ever you forgot what you put into here, you can just open this up and see exactly which video was used in here, and also what all the parameters that were entered for the analysis were here. And you have the trace results, which we are going to use in just a couple of seconds. You can see here, analysis completed, computation time a little bit more than 2 minutes, not too bad. And there were no errors, it's good for us. And we're ready to look at the actual numbers coming out. So let's see how we can use this in a spreadsheet program. So I'm going to use LibreOffice Calc, which compares to Excel or maybe another program, Numeric, and we're going to work with the files in there to get our results. Takes a moment to open again, and here it goes towards text import. The reason is that inside .dat the data are not formatted as in a spreadsheet, but we have to import them into a spreadsheet, and here the settings all seem fairly okay, and we can see here how things are going to be imported. So there's a clear and successful separation into the different columns that we are getting as results here. So you got the length, the width, velocity of sliding, and solidity. You get a couple of rows for that. So let's import it. And yeah, here we are. The data are basically ready to work with. So you can see here the probably most interesting, pardon me, undo fill. The most interesting column would be that one here, where you can see the velocities that were observed in the assay. So you could go here and say you want to have the average of all these velocities. You could go ahead, start formula here, and I'm going to ask for the average and add all these guys And then we will get the average value here, average sliding velocity of 0.64 micrometers per second. And that would be it so far for calculating the velocity for one video from this flow cell. As I would go back here, you can see that there is not just the trace results for this very video from this flow cell, but we actually have the results from all 8. So you can go into the second one, you see there's another trace results, and we can basically go through the same maneuver as before and calculate the sliding velocities for each and every one of them. So far, that I think is the general idea of how this works. Another thing that you should consider at some point is this file here, trace.dist file. This can be used by another piece in the software to execute quality control of the data. So we were trying hard to automate most things inside the software, but there are certain things that human still does way better and more successful as than a computer could do it. And one of them is to drop traces of filaments that were not moving properly in the assay. To do this work, I will open another piece of the software. So here, open, which is called the trace dropper. This is to remove or drop traces of filaments that were not moving properly in the assay. So I'm just going to go ahead and use this one again. Just going to hit run, and up comes the trace dropper here. There are a bunch of axes and images you can work with, but really ideally right after you executed an analysis as we've done it before using the analysis launcher, you would then go and choose a batch that you want to do the quality control for. So let's go choose a batch, and in here you find the trace dropper list file, which is what we want. And you see there are the first images of filaments coming up here. I'm going to make it a little bit bigger so we can see it more precisely. And this here is your main working surface, where you can go and select different traces. So a trace like here, for example, this one looks pretty okay. You can see other traces of filaments like here. They have all sorts of like things coming out at the sides. They don't look smooth, so this one would be rather suspicious. So the task now is to basically go through all the images of filaments here and reject the ones that are not up to our standards. So like this guy or this guy here. You can see here there's sort of like a blow up picture of what the shape of this filament is. You have to watch out, this is not true to scale. This one here is a better orientation point. For example, this one is going to be squished quite heavily compared to here. Anyway, you can see that this one, which is highlighted and selected right now, is not to be kept. So we can see here the keyboard commands to get rid of this filament. You have return, which just takes you to the next trace. So like here, but it doesn't do anything. There is backspace, which I'm going to hit now, which means drop and hide. So you see this one has disappeared, and at the same time we also dropped the trace from the overall data set, which you can see here in this display. You can see that the filaments are displayed by these dots. Here's 0 for the ones that are dropped, or 0 means no, 1 means yes, true, false, and anything you see on the left for false is marked as a filament that will not be included in the data set. So we just moved it from here over to the left side. And there's a bar going through it, meaning that it is hidden and has been scored. And there's also this long bar here, which basically is tracking our progress as we're going along. So this one here is now pointing to another filament, corresponding to the one which is selected here. This one looks okay. So here we want to say that we keep it, but also hide it from this view here. And that would be the spacebar. And you can see here again, it has been crossed out, but it is on the right side, so it is kept. And with these options of keeping or dropping and hiding them at the same time, we can relatively quickly cycle through all the filaments in here. Maybe you can hear the keyboard through the microphone now, and I'm just going to go through it with the space bar and the backspace to sort things quickly. At the same time, you will be able to see how we make progress here. I'm just going to run through the different videos that were recorded and start with this one now. So this is a keeper, keep, 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 yes, 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 good, 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 not good. And you can see immediately after all of them were dealt with, there comes up the next video. So this is, while we have to do this manually, we tried to implement it in a way that you can do this relatively quick and also somewhat pain-free, so you don't have to manually go and click on every single one of these filaments, but you can just score through them very quickly using the keyboard. So it becomes more of an not automated, but more of a standardized workflow that's going to get you there quicker than just working with a mouse and doing everything by hand. So now you can watch how this works at a somewhat quicker speed. So keep, 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 no, no, keep, keep, yes, no, yes, 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 no, yes. So there are sometimes some where you're not sure, and just takes a little bit of eye measure, and you will have to decide what you keep or not. But for many of them, it's actually quite clear. As for this one, keep, no, no, yes, no, no, yes. Now you can also follow my decisions in the right-hand progress bar that displays how we're going through these filaments. So if you, like me, start to wonder how long we're actually going to do this, you can see here, there's the batch file 8 of 8. So this is actually the last image that we're going to be working with. And here you also get displayed which file you're actually currently working on. So there's not so much more to go. I'm going to finish this relatively quick. Nope. Yes. Yes. That's a difficult one, but we keep this. Yes. And as it's telling us, the batch is finished, load next batch, or result folder to continue. So here, we're basically done with this for now. We don't have anything else that we have to go and trace drop as we call it. Everything is done here. I'm just going to close this, and then let's see what we will find now inside of these folders. So you can see here the trace results that we worked with before, and there's also the dropped trace results. So this has just been added by the process that we went through. And let's have a look at what this looks like in the LibreOffice. It's the same import options here as we had before. So let's get that in here, and the same data which are displayed here: filament length, filament width, and the filament velocity. And again, we could go and say here we want the average and put all this in here, and we end up with an average number. But now we can be relatively sure that this is not polluted or somehow affected by any weird filament motion where filaments were just going off to the side or running through each other. So this, I think, would conclude the first tutorial. If there are questions, then probably use one of the methods of contact. And there will be more tutorials coming for more advanced ways or ways to analyze bigger sets of data at a later point in time. So thanks so far, and speak soon.